So now we're looking at simplifying radicals that involve variables. And that adds a little bit of more complexity, to the situation, because depending on what the index is and depending on what the power is of the variable underneath the radical, we might have to use the absolute value. And again, that's mainly because we can't take the square root of a negative number. That's one of the main reasons for this, or we don't know if it's going to be negative or positive, which is why we have to take the absolute value. So in this first problem, we're looking at the square root of b squared. Now remember, there's an invisible 2 out here. When there's no number for the index, it means that it's the square root. Well, 2 is even, so that's an even index, which means we need to use the absolute value. We're tempted to say that the square root of b squared is simply b, but instead, because 2 is an even index, we're taking the square root of something being squared, we have to say that the solution is the absolute value of b. And the reason being is because we don't know if b is positive or negative, and when we're squaring it, that's going to make it positive, which allows us to take the square root. But if we squared, quote unquote negative b, that's also going to be the same value. Negative 2 squared is 4, just like 2 squared is 4, so we have to say that the solution is the absolute value of b. Now when we're looking at part b, we have an odd index, the cube root of w cubed. So we don't need an absolute value here because we're taking a cube root, w's being cubed, the cube root of w cubed is just w. And again, that's because it doesn't matter if w is positive or negative. When you take the cube root, if it's negative, you'll end up with a negative value. When it's positive, you'll end up with a positive value. And again, that's because we have an odd index and an odd power underneath the radical. So when there's an odd index, odd power, in other words, the nth root of a to the n, if n is even, then that means we take the absolute value of the base that's under the radical. If n is odd, we don't take the absolute value under the radical. Part C, we're looking at the 4th root of m to the 4th. Again, that's an even index, even power, and because of that, we have to have the absolute value. So the 4th root of m to the 4th is going to be the absolute value of m. And last but not least, the 5th root of q to the 5th, we have an odd index, an odd root, 5th root, and an odd power, 5th power, and therefore we don't need the absolute value, so the 5th root of q to the 5th is simply q. So again, if we're taking the nth root of a value to the nth power, if n is even, we take the absolute value of whatever that base a is. If n is odd, if the index and power are odd, it's simply the value with no absolute value.